All right, so our next speaker is going to be talking about the dark art of container monitoring. And with that, you better give him a rock star welcome.
Hi everyone, and welcome to the dark art of Kubernetes monitoring. My name is Gianluca. I'm a software engineer at Sysdig, and I'm a core developer of the open source system troubleshooting tool, Sysdig. What are we going to talk about today? Today is going to be pretty much all focused on monitoring and troubleshooting Kubernetes and applications running inside Kubernetes. Let's start by having me presenting the simple demo environment that I have here, where I essentially have a Kubernetes cluster running 2 namespaces, and on each of these namespaces, I have tons of applications running. I have some WordPress stack, I have a Java application running on top of Tomcat, and then I have tons of databases, and each of those components follows the best practices of Kubernetes. So each of those components lives in a separate pod, and each of those pods is automatically managed by a replication controller, and the components interact with each other using services and the Sky DNS extension, so that I get a nice DNS user-friendly name as well as a virtual static IP address for my services. So this is all very cool, but when it comes to troubleshooting, this becomes essentially a living hell. So this is a real nightmare, because now I have all my processes running in the system in separate containers, and some of them are running on the same host, others are running on different hosts. So I have all the layer of virtual networking on top of everything. So if I want to see what's actually happening under the hood, it's quite challenging. So in these cases, you really need to know what to look for and how to look for it. So what are some of the tools that can help me make some clarity out of it? In the Kubernetes ecosystem, we have a pretty good amount of monitoring tool. So I can, for example, use the Kubernetes UI for doing some passive exploration of the Kubernetes entities across the cluster. Or if I want to monitor my containers from a system resource point of view, I can use cAdvisor. And if I want to get fancy, I can essentially correlate this information that cAdvisor provides with their respective Kubernetes labels using Hipster. And then finally, I can use a visualization tool such as Grafana that allows me to print all sorts of dashboards for my services and all that. But if you are anything like me, you'll find yourself wanting more. You'll want to know much more of your infrastructure. You'll want to know what kind of network activity is going on inside your namespace, or what kind of files a specific group of pods you're touching, or what transaction is a database serving in a specific namespace, or just what's the overall health of your application. So in order to answer these questions, you need to do what I call troubleshooting like a real man. So essentially, you need to get the system resource that you're interested in monitoring, and then you really need to get deep in there using the system troubleshooting tools that we've had for many years at this point, which work very well and provide us a lot of detail. The problem with this is that most of these tools are not extremely optimized for containers, let alone for Kubernetes. So using them in a containerized environment presents a lot of challenges. So today, I want to talk to you about this little guy up here in the top right corner called Sysdig. Sysdig is an open source system troubleshooting tool that is meant to be a TCP dump for your entire system. So it doesn't only work with network packets, but it works with system events. So with system call. It's a system called Sniffer that allows you to get all this data, filter it in a very smart way, and run useful scripts on all this data. It is completely open source, and most important for the talk of today, it has native support for Kubernetes, which has just been released a couple days ago, and I'm very excited to show it to you today. So let's get rid of these slides, and let's jump into action. So in its simplest invocation, as I said, Sysdig is just a system called Sniffer, so it's not very user-friendly. It will just print me on screen all the system events that are happening in my system. And so this is a lot of noise. But as I said before, you can filter these system events. So if I type sysdig-l, let me make it a little bit smaller. OK. If I type sysdig-l, I get access to all sorts of filters that I can use to limit the scope of what gets printed in screen. So I can filter on file types, process attributes, network attributes. And most important for today, I can filter for Kubernetes attributes. So I can pick a pod, a replication controller, a service, or a namespace, and I can filter by its name, ID, or specific set of label. So for example, if I do sysdig, and then I do kubernetes.pod.label.name equal MySQL, this will just show me on screen all the system events done by the MySQL process in one pod whose label contains the key name and the value MySQL, which in this case I can see these two pods. I have this MySQL MV and the MySQL BL. So depending on what I'm looking for, with filters I can get very selective and I can do some extremely good troubleshooting. But sometimes this is still too much. So the other option is to have these events processed by our Lua scripting engine, which we call Chisel. And it provides a completely different approach. So what I can do is that if I run with -c, now I see on the screen all dozens of Chisel that we support by default. And if I do, for example, let's pick one, top file bytes, now I get user-friendly output where I'm seeing the I/O of the system broken down by individual file name and by individual container. This on Linux is a metric that is very hard to get. There are not many tools around that can get to such a big level of visibility, especially inside containers. So this is something that we are very proud of. And of course, I can apply this Chisel also to the Kubernetes entity. So I can do, for example, show me the byte activity grouped by the Kubernetes.namespace.name. And now I see that I have two namespaces in my system, as I said before, dev and prod namespace. And each of them is doing about 200 kilobytes per second of file activity. So this is very useful. And with Chisel, you can have a very good top-down approach to troubleshooting. But what's even better for us is using sysdig. Sysdig is our cursor-based UI for sysdig. And once I open it, I see an output that is pretty much similar to top, right? Where you can see all your processes in real time, along with the system resources that they are consuming. But look here, I have an interesting column, which is called container, where it will show me the container name when these processes are leaving. Because for sysdig, containers are first-class citizens, and so we give them a lot of importance, and this can become very handy during troubleshooting. But this talk is focused on Kubernetes. So if I press F2, I get to the views panel, where I can essentially see all sorts of troubleshooting views that I can apply to my system, depending on what I'm looking for. So here we are talking about Kubernetes. So let's switch to this set of view. It's called Kubernetes namespaces. And now I'm seeing all the namespaces in my system, along with their ID, name, and set of labels, and the system resources that they are consuming. So a view like this is very useful to give essentially give it a quick troubleshooting to check if my namespaces are behaving well. And if I select one namespace by pressing Enter, I can do what we call the drill down, and I get to a view where I now see all the pods in this specific namespace. And here I can see each pod with their ID, namespace, and set of labels, along with the system resources that they are consuming. And this is very cool. So one of the questions that I had was, before in my slide was, how do I monitor the transactions of my database? Let's use sysdig. So if I select, for example, the Redis pod, and I drill down into it, now I get to a view where I'm seeing the specific container that this pod is running. And I see the container view. But in this case, I'm interested in the network activity. So I can move to the views panel and select connections. And now I'm seeing the specific TCP connection that this Redis process inside this specific pod and namespace. The specific connection that this pod and namespace is doing. So if you clapped, wait until you see the end of it. So wouldn't it be nice if I could see what's actually going on in this connection without doing all the sort of TCP dump, discovery, what kind of virtual interfaces for this container and all sorts of things? Yes, because we use system call. So by doing F5, I enter into echo mode, where I can actually see the I/O buffers exchange on this connection by the process, which, if you have ever done some Redis programming, you'll recognize that this is the typical Redis protocol, where I'm incrementing a counter, and then I'm getting its value. So this is very cool, because it's done by a completely separate application, and you can get really deep into your Kubernetes application. Then, another thing that I wanted to see was, for example, how my services are behaving in terms of controllers. So if I switch to the controller view, now I'm just seeing all the replication controllers in this specific namespace, along with their set of labels. And if I drill down into one, for example, this WordPress, I see the replicas. So here I see the 3 pods for this specific replication controller. And in CCSD, we added some eye candy by providing shortcuts to kube control. So if I select a pod and I press F, I get into the follow log, where I can see the logs for this specific pod. Or even better, I can, for example, if I really have to, press B, and I am dropped into a bash shell inside the first container of the pod, which is essentially a very nice shortcut to kube control. And all these commands are worth exploring, but we don't have a lot of time, so let me just focus on one more, which is once I'm inside my namespace, for example, let's go into the SPY users view. And this will show me all the commands that are being executed in my namespace, which is incredibly useful. So in this case, I can see that I have a bunch of client containers that are doing some sort of curl. And look how they are using as a DNS name for the HTTP server. They are using essentially the Sky DNS, automatically generated DNS entry point, where I have service name, .namespace, .service, .cluster, .local. So this is incredibly useful, and all these views, as I said, are extremely worth exploring. And before switching to something else, SysD can not only be used for troubleshooting your application running on Kubernetes, but also it can be used for troubleshooting Kubernetes itself. So if I go into the processes view that I was seeing before, which seemed quite boring at the beginning, and if I filter by etcd, now I'm able to see the system resources that etcd is consuming, which of course is a critical component of Kubernetes. And wouldn't it be nice if I could see the network activity that this etcd is doing? And I can actually press, once again, do the trick of pressing F5, and now I can see the I/O buffers, which is essentially the HTTP requests that etcd is serving. So this is very interesting, a little bit advanced, but this is interesting. So this shows you how SkyDNS works. So every time you go on port 53 of SkyDNS and do a host resolution, SkyDNS generates a etcd query by asking, for example, mysql.prod.service.cluster.local, and etcd will return a JSON that, among other information, will contain the IP address of the service, the virtual IP address, which will then be returned to the program asking the DNS resolution, in this case my curl, and everything will work smoothly and in a completely almost magical way. But by using something like that, you're able to troubleshoot at a very low level what's going on even in your Kubernetes cluster. So this is essentially most of the things that I wanted to talk about. There is one more thing, which is what happens if I am in a multi-node environment? Because of course, you would be crazy to use such a nice toy like Kubernetes on a single node. You have to put it on dozens of nodes and stuff. And of course, the approach of SSH into each one of your nodes and running these tools is not very appealing, at least to me. So at SysD, we thought about this, and we said, what happened if we took all these system events, all these system calls on all my nodes, and what happens if I correlate them to a centralized place? And what happens is what we call SysD Cloud. So SysD Cloud is our distributed infrastructure monitoring and troubleshooting tool. And here I have in SysD Cloud essentially the same application that I was running on my laptop, but on a 4-node Kubernetes cluster where I have 1 master and 3 slaves. And here I can see all the system resources that each slave is consuming. And if I expand each node, I see the containers along with all their system resources that they are consuming. So this is very handy. Oops. This is very handy. One thing that I like a lot is that I can, for example, filter by WordPress, and now I'm able to see all the 6 WordPress containers that are making my Kubernetes application. But still, it's not ideal because I know that some of these containers live in a separate namespace or something, and these hosts are in the way. So the first thing that we thought about was, let's remove the host from the hierarchy, and let's just look at the containers, like here. So now I'm seeing all the containers in my cluster, regardless of the host where they're scheduled. But we can do more. Let's, for example, group all these containers by their namespace name. So now finally I see dev and prod. And if I expand each of those, I get the individual containers along with the resources that they are consuming. And if I even want to get fancier, I can, for example, introduce the replication controllers into the picture. So now I'm seeing, for my namespace, I can see all the replication controllers, and I can expand each replication controller and see the pods, and I can expand each pod and see the containers. What I really find amazing is this column. So now, by getting the host out of the way, I'm able to monitor my service as a whole thing, regardless of where the individual pods were scheduled. And I'm able to even see, by looking at the system calls, that's pretty advanced stuff. So if I can click on one, and for example, I go into an HTTP view, now I'm able to see all the HTTP requests that the entire replication controller in this namespace is doing, which is quite unique because I didn't touch in any way their pods. I just sniffed all the system calls or all the nodes. And I can even get to some greater visualizations. For example, if I select the whole namespace and I look at the topology, now I'm seeing essentially a map of how my replication controllers are interacting with each other. So here I have, you can see that the WordPress replication controller is talking to MySQL, and the Java application is talking to a bunch of databases. And if I expand each replication controller, I get to the pod view. So I get the individual pod, how they're interacting with their databases. And I can expand each pod and get to a view where I can see the individual container and the individual process that it's talking to the other components in the system. So depending on what you're looking to troubleshoot, this is quite cool. And don't take visualizations like this for granted, because if we go and take a look, for example, at the topology of that application without taking under consideration the Kubernetes entities. So if I just choose to look at a map, just on my previous view, look at how this is a real clusterfuck, because I see all those containers, but I have no idea who they're communicating with. And so by introducing the semantics of the Kubernetes entities, I am able to get some really cool data. And if I can correlate this with the system calls coming from a really deep source of information, I can do pretty amazing things, we like to think. And this is pretty much what I wanted to talk about. If you have more questions or if you want to get more information about this, feel free to stop by our booth. Otherwise, thanks a lot.
You should hold this, and then you should drop it. So we have time for a bit of Q&A, so if you can unplug and step to the side, we'll have our next speaker come up. Do you want to try it? Hold on. We need something soft. You should drop it. Just drop it a little bit.
Just a little bit, like this? Okay. Like this? Okay.
And repeat the question. There's a question in the back, and go ahead and repeat it.
So the question was, are there any plans to bring the SysD Cloud functionality to the cursor interface? That's a good question. For the moment, we like to think that the components really complement each other. So you can start your exploration by sysdig cloud and then go deeper with sysdig. So they definitely serve different purposes. But we might not exclude that in the future we might add multi-node capabilities to a single sysdig instance, although for the moment nothing is planned on that.
Did it come up there? I don't know. You have to put your thing. Come on, one down.
Are there any plans to integrating with horizontal Kubernetes also scaling, and this is the agent monitor? That's something that we thought about it. Our Kubernetes support has just been released, so we are eagerly looking for feedback both on the open source and commercial part and the sysdig cloud part. So I will be definitely happy to talk more about your specific use case, and the short answer is yes, if it's useful, it might and will definitely get implemented. I can see it there. Yes. Oh, okay. So the answer is, what happens if on your network connection you're having binary data? So the answer to this is, short answer is sysdig sees all the buffers. So if you want, you can write a Chisel to do your own dissection. There is something that we already do. For example, sysdig cloud is based on the same data as here. I just showed you the HTTP data, but we, for example, can get MySQL or Postgres data, which is half binary. And what we did was exactly the same. So we sniffed the system calls, and we implemented a decoder, which in the open source can be implemented as for example, a Chisel in Lua. We already have an HTTP decoder, which is open source and in Chisels, although that's much easier than a full binary one because HTTP is all hashy. Yeah.
All right, thank you.